Swayam Prabha. Digital India. Educated India.
Friends, let's move to lecture number 18, where we are going to discuss about processing of metal matrix composite. Last class what we went through was what is metal matrix composite, what are the different types of metal matrices, what are the different types of reinforcement, what are the different types of forms of reinforcement. This is what we saw. Basically in the matrix we saw that it is aluminium, it is titanium, it can be copper, it can be magnesium. If you want to have a very high temperature application, you can have cobalt. Then you can also have cobalt nickel alloy mixed for those applications. And as far as reinforcement is concerned, we had particulate reinforcement, whisker reinforcement, short fiber reinforcement and continuous fiber reinforcement. So today what we will do is we will go through some of the processes which are commonly used for making metal matrix composites. So we will see introduction, followed by introduction we will see different processing methods. Then here we will see some of the liquid state processing of metal matrix composites. So it is stir casting is a process, infiltration is a process. In infiltration you can use gas pressure, you can use squeeze casting, you can use pressure dye. Processing of metal matrix composite. In processing of metal matrix composite, you have many different techniques. So what you have to do is you have to a suitable process is engineered such that you have a desired kind, quantity and the distribution of reinforcement components in terms of particles and fibers. By altering the manufacturing methods, the processing and the finishing as well as by the form of the reinforcement component, it is possible to obtain different characteristics profile, although the same composition and amount of the components are involved. So by just playing with the process parameters, you can even try to change the mechanical properties for your requirements. So the processing methods can be classified into liquid state, in situ process. Liquid state is you start the matrix in a liquid form and then you try to make a composite. That is what is called as liquid state. So the vice versa, you can also have a solid state, you can have something called as a deposition technique, you can also have something called as in situ technique. In situ techniques are basically I take A plus B, I just put A plus B and then maintain a constant, I maintain some pressure or some temperature, A and B reacts and in situ it forms a composites. So those things are called as in situ processes. Liquid state, the metal whatever is there is converted into a liquid metal or an alloy is there, it gets converted into a liquid alloy. Then this liquid alloy is poured in the ceramic net, or the ceramic is added to the liquid state of the metal and then finally we try to cast it to get a required product out. So those processes are called as liquid state process. What is solid state process? I try to take a metal, for a simple example, I try to take a metal foil. I take 10 metal foil layers and in between the two foil layers, I try to keep some reinforcement. So this reinforcement can be a metal reinforcement or it can be a carbon fiber reinforcement or even a glass fiber reinforcement. So when I say carbon fiber, glass fiber in solid state, I can even keep a continuous fiber, I can also keep a mat. And then I stack them all in the required orientation whatever I need and then I apply pressure and temperature. So the metal melts and diffuses into the reinforcement such that you can try to get the required output. So this is, you have a sintering forging there and you also have something called as diffusion bonding. In liquid state fabrication, what happens is we take that try to take a molten metal and then disperse a phase into a molten metal. It's like you have a liquid, molten liquid, let's take water, and then you have this NaCl. You just throw NaCl into water. So here in this case NaCl dissolves, but assume that it does not dissolve. So what happens? It gets mixed into the water, and assume that you just put it inside a freezer. You freeze it. So when you freeze it, all these dispersed particles stay wherever they are, and the matrix gets frozen, and then you try to get the composite. So in order to provide a very high level mechanical properties, the good interface bonding is very, very important. So people look, that's why people look into what is the surface energy of the ceramic particle, or what is the basic nature of the matrix. Can these two fellows gel with each other? And if it gels properly, then there is a proper interface. If there is a weak interface, what happens is, suppose you have a weak interface, these interfaces, this is a ceramic material, so this interface will just drop out, fall out, because there is not much of proper bonding with this fellow with the matrix. So when it falls out, it creates dent. So this is why we always talk about good interfacial bond in metal matrix composite. So between the dispersed phase and the liquid matrix, it is to be obtained. The wetting property can be improved. So it's okay. So suppose you decide, I wanted to take aluminium and I wanted to take this as alumina, but alumina and aluminium does not gel properly. Assume it does not gel properly, but still, what is the way out? The only way out left to you is between this alumina and the aluminium. So you try to coat one more layer with this layer, which can try to help in locking of these particles in the base matrix. So a wettability improvement can be achieved by coating the dispersed phase particle. It can be a fiber, it can be a particulate, or it can be a whisker. So it tries to coat them, and after coating you try to disperse them. So when it tries to do it, there is a good interface strength which is happening. So a proper coating not only reduces the interfacial energy, but also prevents chemical interaction between the dispersed phase and the matrix, so that you can get a required output. So stir casting and infiltration. In infiltration you can have gas pressure infiltration, you can have pressure die infiltration, you can also have something called as squeeze casting infiltration. We will see them all, these process one by one. First is stir casting process. So in stir casting process, so this is the basic process, and majority of the researchers who work in metal matrix composites for various applications, they try to use the stir casting process. Stir casting process, if you want to develop a setup, it is very economical. So all you have to do is, you have to have a bucket, or it is called as a crucible. So this crucible is filled with a metal alloy, whichever you want to take. This can be aluminium, this can be copper, this can be titanium, this can be whatever, cobalt, this can be Mg, whatever you want. So it tries to mix it. Okay, you try to first heat it to a higher temperature, and then what you do is, you try to, if you want, you can also try to maintain the atmosphere. Heating is done, so the alloys get melted. So once it is melted, what you do is, you use a stirrer, and then this stirrer is used for stirring and uniformly distributing the heat amongst the metal. So it does a convection. So this tries to distribute the heat, so that uniform melting has happened all along at a certain viscosity, which you have already done some experiments. You have figured out which is the right viscosity. You try to disperse the reinforcement into the metal. So here it can be alumina, it can be SiC, it can be TiC, it can be TiCN, whatever it is. So it is not necessary you should use only one reinforcement. You can also use a combination of 2-3 reinforcement mixed. So this is mixed, and the reinforcement is dispersed now inside the molten metal, and even after dispersing, then the stirrer still keeps continuing. So the stirrer's basic function is first to maintain uniform heat in the molten state, and then when there is a disbursement of ceramic happening, these dispersed particles should be uniformly distributed, such that it gets a very high mechanical properties. So this process is called as stir casting process, and after the stir casting, if you want, you allow it to solidify. If you want, you take this mixed one and pour it inside a mold or inside a die to get a required output. It can also be used, it can also be poured, and then it can be used for injection molding also. Metal injection molding also can be done, so that you try to get the required product out. So here the starting material predominantly will be only two. One is particulate and the other one is whisker. But whisker is always a challenge, so we always choose particulate and then try to disperse it. So here, depending upon the crucible size, you can have 1 kilo yield or 1 liter yield, you can have 10, you can have 100, depending upon the crucible. When the crucible goes larger and larger, the heat application also should be taken care. So this heat, the heater also should, rating will increase. If you want, you maintain it at vacuum, or you can do it at free atmosphere. So here copper also people do it. Aluminium they use it very exhaustively, copper they use it. Some people have also used titanium. Magnesium has some difficulty in processing through this route, so people don't use it. So this is a typical setup which is commercially available. So these are the, and what are the process parameters is, one is temperature. Suppose you have a vacuum, so you have to maintain vacuum. Then you have to have a rotary speed. Very, very important. So this rotary speed is used, and then this is trying to disperse the particles. You can see that you can reinforcement separately, or you can allow the reinforcement to pass through the stirrer, and it can be done. So this is a controlled process, and you get the required output. So here once everything is done on the top, there is something called as bottom pouring. So here what happens, this bottom pouring, suppose if there is a lid, this lid is opened out and everything is collected at the bottom into a vessel, and then it is used for casting process. So that is why it is called as stir casting. You are stirring it and then finally you cast it to get the required output. Stir casting is characterized by the following features. The content of the dispersed phase is limited. So here you cannot go more than 30% volume fraction. Should keep that in mind. So why is that very important? Suppose you want to make really a lightweight composite, metal matrix composite, you keep adding more and more and more dispersed ceramic particles, you disperse it. Moment you disperse it, it becomes lighter and lighter and lighter. So if you have more amount of volume fraction of ceramic materials, then there is a problem of agglomeration. So in order to have a proper distribution, the maximum best possible is 30 volume fraction. However, this can be enhanced up to 60% by taking proper care and doing necessary modifications in the setup. You can definitely get it done. So the next one is the distribution of the dispersed phase throughout the metal matrix composite is not perfectly homogeneous. So in order to have that, what we do is we try to always functionalize the particle. The next thing is the ceramics are always light in weight. The metal, if it has a higher density, then there is a problem of gravity which comes, and these ceramic particles don't get mixed at the bottom, they always stay at the top. So there may be a gravity segregation of the dispersion because of the density difference. This is very, very important. So you might get a metal matrix composite, liquid might be there, ceramics might be on the top of it. So if you look at it, the ceramics will be, the liquid will be here, and all the ceramic particles will be placed here. If there is a density difference, it will be there. And when you try to pour, the first few set, all the ceramic particles get inside. And afterwards, you get whatever you get filled up in the die is only the metal. So this is a very, very serious issue. You have to keep this in mind and try to sort it out. The technology is relatively simple, because of that it is very less expensive. The distribution of dispersion phase may be improved if the matrix is in a semi-solid condition. So that is why people call it as mushy state, or Rio casting. So today the stir casting methods are the method using for stir casting in a semi-solid state is also called as Rio casting. So rather than taking it to a liquid, so basically what you are trying to do, you have a solid, you convert it into liquid and then try to freeze it and get back a solid. Rather than doing it, I try to take a solid, bring it to a mushy state. So I apply lesser energy, but the viscosity is there. So I have to make sure that viscosity plays an important role for dispersion. Keep that in mind and then add the ceramic particle and quickly freeze. So by doing this, you are trying to reduce the time, you are also trying to reduce the energy which is used. But there are other implications which you have to make sure. The next one is infiltration. Infiltration, by the English meaning itself, it says that you are trying to push somebody inside between the holes. So here the somebody which is pushed inside is a liquid. So how can you push a liquid inside? Either by a positive pressure or by a negative pressure. So the infiltration is a liquid state method of composite fabrication in which a preformed dispersed phase is soaked in a molten metal matrix with which fills the space between the dispersion phase inclusions. The motivation force of infiltration process may be either capillary force of dispersion phase or an external pressure, which that is what I told you. It can be gaseous, it can be mechanical, it can be electromagnetic, it can be centrifugal, or it can be through ultrasonic. The liquid phase is forced inside the infiltration. So if it is by capillary vacuum, it is called as spontaneous infiltration. If it is pushed intentionally, it is called as forced infiltration. So now quickly what all should come to your mind? Whatever is the dispersed phase. Now I cannot have just particles there. So it has, these particles should be in some form. So when it is some form, it has to be stiff enough for the metal to get infused. So these are some of the difficulties. So the infiltration is one of the method for preparing tungsten copper composite, is one of the methods. I said there are many methods and any metal matrix composite can be produced by any process, but you always look at the best output in terms of energy, in terms of performance. Okay, then you choose it. So here infiltration, the mixing of titanium powder with a binder, then it is compacting of the powder by a molding method, then you sinter the green compact to such a high degree, so 1200 to 1300 degrees Celsius, it is degrees Celsius, in a hydrogen atmosphere, so that you do not have any reaction getting formed. Place the sintered part of the carbon plate in the infiltration or in a sintering furnace. The infiltration of the sintered tungsten porous structure with copper at this temperature in either hydrogen or in vacuum for 1 hour, what happens is the copper gets infused inside the tungsten, or the tungsten particles try to give this is a reinforcement. So finally, how does it look like? So you have particles, these particles are bound, okay, and then this is a free space. So in this copper comes. So this is an infiltration method wherein which copper is infused inside the tungsten, it is a preform. Okay. So gas pressure infiltration, the gas pressure infiltration method is used for making very large composite parts made out of metal matrix composite. The method allows using non-coated fibers due to short contact time of the fiber with the hot metal. In contrast to this method, using mechanical force, gas pressure infiltration results in lower damage to the pressure. Basically what happens is you have a reinforcement preform, which is nothing but the reinforcement. If you try to push this fellow with gas, okay, and what are you pushing? You are trying to push a metal, and this is in the molten form. So then what happens, the preform whatever is there does not get damaged, the metal gets reinforced and then tries to produce an output. So this is the gas infiltration which is by pressure. So what we do is we have a container, we have metal, we have a preform whatever is there, and now what we do is we apply pressure through this. When we apply pressure through this, the liquid whatever is present there tries to get infused into the preform and try to make a composite. So this is a composite. You can use it positive pressure, you can use a negative pressure, and here this gas plays a very important role. You can also have this gas, you can also choose this gas to have reactions. You can also have a inert gas so that you don't want any reactions to happen. The last one in the infiltration process discussion is going to be squeeze casting. Squeeze casting is you squeeze, you apply force. So here it was not applied, it was force applied through gas pressure, right? But here what we are trying to do is we are trying to squeeze, we are trying to pressurize, we are trying to inject metal in a very high pressure. So squeeze casting infiltration is a process wherein is a forced infiltration method wherein which the liquid phase is moved, is pushed by applying a pressure. By applying this pressure, but this pressure tries to be exerted on the metal and this tries to infuse and then try to produce an output. A simple example is the piston, aluminium pistons. So in the piston you have a crown. So this is a crown. So here what we do is we try to reinforce with ceramic particles, and these ceramic particles are infused with molten metal like aluminium. So here this is alloy, this is a metal matrix alloy, metal matrix composite, and it is only at the top so that you try to get. So here it gives you wear resistance, it also gives you the thermal wear resistance. That means to say when the spark hits, nothing gets eroded on the surface because there is a ceramic also protecting the metal. So squeeze casting infiltration is similar to that of squeeze casting other techniques used in the metal matrix alloy castings. So here the process is a preform of a dispersed phase. It can be a particle, it can be a fiber, is placed inside a mold. It's placed inside a mold, and then what we do is the molten metal is in a predetermined amount is poured into the mold. Then what we do is we try to use, so you can see the figure here. Okay, so first what we do is we put a preform, we try to put the liquid metal on the top, and then we try to use a ram, a press. We use a press. So this press, what it does is it tries to hit at the metal, and then this metal is now pushed into the space whatever is there in the reinforcement, and thus we get a metal matrix composite. So here it is called as squeeze casting infiltration. The first one what we saw was, it was gas pressure infiltration. Here it is mechanical squeeze cast infiltration. So here you can use aluminium, you can use copper, you can use titanium, you can use cobalt, whatever you want. And apart from this, you can also use many other things. Today people are started using rare earth metals also getting mixed. And here the important aspect is an injecting pin. The injecting pin is used to release the composite after the composite is fabricated. So till it was squeeze casting, then it is pressure die casting. So in pressure die casting, the pressure die infiltration is a forced infiltration method of a liquid phase fabrication of metal matrix composite in the die casting technology, where when the preform is dispersed phase is placed into a die which is filled with a molten material, enters the die through a sprue and then gets so this is the way we do it. So here is a molten metal. the challenge. This is a challenge. It is not so easy. Pictorially it looks very easy. This is a big challenge. You try to take a liquid metal, try to maintain the temperature of the liquid metal. Why is that important? So that this is the challenge is directly viscosity measurement. Viscosity, not measurement, viscosity maintaining. So this has to be in a form such that it is in a liquid form, and this liquid form is used to, the plunger is used to pressurize. It goes through a sprue, and then here is a preform. Placing the preform is also a challenge. Placement of preform. Why? Because of this very high pressure, the preform gets displaced. Moment it gets displaced, you will not have a quality product. So what people have started doing is they are trying to add, like in casting, they are also trying to add some spacers, and these spacers are again a ceramic material, and they are becoming later integral part of the component. Integral part of the component. So moment they have made as an integral part of the component, so then this also stays there for rest of its life. So, so we have to choose a proper spacer so that we maintain it. So these are the ejecting pins for removing the components freely as and when it is made. So with this we come to conclusion. So what we covered today was, we just looked into only one type of one set of liquid state fabrication process of metal matrix composite. In the next lecture we will see other processes also. The most simplest one which is used is stir casting process. The from the application point of view, from quality point of view, performance point of view, we always go for infiltration techniques. These infiltration techniques can be done by gas, it can be done by squeeze, it can be done by pressure. So in gas what we do is, we just apply a gas pressure on top of it, and we make sure that wherever there is a space in the preform of ceramics, this gets diffused. Then we also, what is diffusion? Diffusion always happens when there is a concentration difference. So there is a diffusion happening. So then squeeze is, what we do is, we try to apply pressure, mechanical force, and then we try to squeeze it. When in pressure die, the pressures are phenomenally high, which is used to inject the metal into the preform such that we get the good quality output. So pressure die casting, aluminium pistons are made out of pressure die casting. Squeeze casting, they are used for making very large area parts, and there has to be a preform. Okay. So with this we come to an end of this lecture. So we would an assignment, which is again a self study for you, is, now if somebody approaches you that he wants to make a turbine blade for a high speed jet engine, which metal matrix composite will you choose, and what is the fabrication process will you suggest for making such blades? So when you try to say the second question answer, try to write it in a tabular form. Try to compare with process X, process Y, process Z, and then try to say these are the salient points for each process. I say very good, good, excellent, whatever it is. So please try to make it in a table form and compare, and then conclude which is the best fabrication process do you suggest for making this turbine blades for high speed jet engines. Thank you very much.